For today, we are going to focus on a specific type of exponential and log equations, the one that we can simply solve through what we have learned. Okay, so here, this is the simplest case. If we have an exponential form of, let me do this, okay, a to the power x equal to b. This is a exponential equation where a and b both are constants and a variable x. And last time we discussed something like 2 to the power x equal to 8. And I mentioned that if you have something like 2 to the power x equal to 8, you can write this 2 to the power x equal to 2 to the power 3. Therefore, the bases are equal, so you can compare the exponent. But here is the problem. It's not always possible that you can write this base to be equal. So what you can do is, you can use one of the properties of log. So here, what we can do is, you can take a log from both sides of the equality. So I have a to the power x and b, and I take a log from both sides. And I can pick a base for the log. Whatever base I pick on one side, I should pick the same base. I'll pick base a, base a. Now, what is the property that I know about log a to the x base a? If you remember, this is a composition of an exponential with a log. So these two are inverses of each other. They work as if you have square root of x squared. It's an opposite operation, simply x. Let's say x cubed, just to make sure. It's x. Okay. In the other case, I should mention that x is positive, otherwise the result of absolute square root is always, it's not always positive. It's not always the same as x, it's absolute value. So what I want to mention is that if you compose a function with its inverse, the result is always x. So this is x. And what do I have on the right side is log b base a. So I can say, if you have the equation a to the power x equal to b, what is the solution? The solution is x equals log b base a. I can just go through this process always. So here, for example, let's try to solve 2 to the power x equal to 5. What do? I'll take a log from both sides of the equality. This is not multiplying. You operate log on both of these two. It's like if you say I have x squared equal to 5, what you do is you do not multiply square root to both sides. This is not correct because I've seen this mistakes, so I'm going to mention it. You operate square root on both sides. This is what normally you do. The same with log. You do not multiply the log operates. So log operates on 2 to the power x as well as on 5. What can I pick as base? I can pick base 2. Just because the exponential is base 2, it's easier for me to pick base 2. Left hand side simply turns out to be x by the properties of log. Right hand side is log 5 base 2. You may ask yourself, what is log 5 base 2? I didn't calculate that. That is not our problem because we solve for x. X is simply equal to this number, whatever that number is. You can use your calculator and say, figure out what is log 5 base 2 just by you typing in the calculator. Sometimes your calculator does not have the decimal form. So what you can do is you can write this as log 5 divided by log 10 by log 2. By the change of base property, you can simply do that and you can calculate. It should be some decimal number, whatever that decimal number is. Something like 2 point whatever. I don't know exactly. On the exam, normally they want you to type in the exact value. Unless they ask you for the decimal, you type in this exact one. Okay. Here, let's try another one. E to the power x minus 1 minus 6 equal to 0. Here, if I want to solve this equation, I will try to get rid of the 6, add 6 to both sides. We'll get e to the x minus 1 equals 6. Therefore, now I have an exponential and a constant. I can take a log from both sides. What do I pick for the base? I'll pick the base e, so I can take an ln from both sides. ln e to the x minus 1 equals ln 6. Left hand side, the composition of ln with the exponential simply turns out to be x minus 1. And right hand side, I have ln 6. I do not know what ln 6 is. Again, this is just a number. It's a decimal number. So what is x? Add 1 to both sides. 1 plus ln 6. Let me write this ln like that. So this way, it's a natural log. It's not 1n or something. So ln of x equals 1 plus ln 6. This would be the answer to this question. It's not super complicated. It's just you make sure to pick the right base and you operate the same way. If you take a log base 2 from one side, you should do the same thing on the other side. So here's another example. It's already written in the form of a to some power equal to a constant. What you can do is you can take a log from both sides. Log base 2. Log base 2. Again, normally you pick the same base as the base of the exponential. In this case, it's 2 as the base, 3x minus 1. This, there is an idea that you can drag this down by the properties that we learned and write as a coefficient and say a log 2 base 2 is simply 1. But we already learned that if you have log a to the power x, the result is always x. Doesn't really matter what this x is. It would be 3x minus 1, you'll get 3x minus 1. If it's 2x, x minus 1 like the last time, it would be x minus 1. So here in this case, log 2 to the 3x minus 1 base 2 is simply 3x minus 1. Right side is log 5 base 2. You can add the 1 and divide by 3. You can figure out what x is. 1 plus log 5 base 2 divided by 3. So this is the answer to this question. You can always, again, turn this into decimal by using the calculator. This is the easiest case. But sometimes they give you a question like this one. This is a specific case that I want to focus on, because not always you'll get this format. Most of the time you get this simple cases that you can take a log. Okay, before I get into this example, I want to mention something like e to the power x and e to the power 2x. I want you to see the relation between these two. What is e to the power 2x? You can think about it as e to the power x to the power 2. Because this means e to the power x times 2 or 2 times x, the same meaning. Right? So if I have e to the power 2x and you call this a variable, you call this z or whatever, what you have is e to the power 2x is basically z squared. If you have e to the power 3x, this would be z cubed. If you have e to the power x plus 1, then this is not z to the power, this is not z plus 1. Do not make this mistake. This is not correct. This, you can use another fact that e to the power x plus 1 means e to the power x times e to the power 1. Then this is z times e. It doesn't make it simpler, but I want you to see the relation. So let's ignore this very last one. I need to see that if you multiply a constant to the exponent, it just works as a power. What I'm going to do is I'm going to use this idea and say, if you have e to the power x and e to the power 2x in an equation, you can replace them by a specific variable. You can call this variable z, e to the power x, I'm going to call it z. So what I have is z squared minus z minus 6 equals 0. So now, what can I do? I can factor. This is a quadratic equation. You can factor it. If it's not possible, use the quadratic formula. So what can I do is I can say z minus 3, in this case, times z plus 2 equals 0. Right? Multiply these two numbers gives you -2, -6, and add them up, you get -1. So what is z? Either z minus 3 equals to 0, which means z equals to 3, or z equals to -2. You have two equations, and the results are z equals to 3 and -2. At this point, you're not done for the question. You're done with this z variable. What was z? Z is e to the power x. So what did I get is e to the power x equals to 3 or e to the power x equals -2. Here is the important part. You can solve each one simply by using the same idea that we did. I can say, I can take an ln from both sides. So ln e to the power x equals ln3. So what is x? X equals ln3, because ln e to the x is simply x. I can do the same thing for the other side. I say ln e to the x equals to ln -2. These parentheses. So what do I have as an x? X equals ln -2. Okay. Normally, if you use calculator, you will get error at this point. But just to make sure that you understand, if you remember, the domain of log function was always positive values. You could put a 3 inside the log function, but you can never have -2 inside. So in this case of x equal to ln -2, this is not acceptable. You cannot do this. And that's because you can never have an exponential function equal to a negative number. You can never have 2 to the power x outcome to be a negative value. If you remember, the graph exponential was always above the x-axis. So this is not possible. So this solution ln x equal to -2, x equal to ln -2, this is not acceptable. So what is the solution? The only solution that you have is, you can say x equal to ln3 is the only solution. You can use decimal value if you want. Okay, so generally, if your equation is in this format that involves e to the power 2x and e to the power x, this is what you do. You change the variable. They're always the same thing. Turn into quadratic equation and solve it. Okay. Here, that's most basic ones for exponential. Most of the time, this is the topic, the examples that you deal with. Nothing more complicated than that. There's one more. I don't know if I should mention it, but at the end, maybe I'll mention that one as well. So let's deal with the simple cases first. Let's say solving log a base b equal to c. If you want to solve logarithmic now, what you can do is, it's the same thing. If you had square root of x equal to 5 and they ask you to figure out what is x, you do opposite operation. You square both sides and say x must be 25. So last time we had x squared equal to 5 and you operate by taking a square root. Now here, if you're given the square root, what do you do? You operate the opposite way. Or you can think, okay, I have a logarithmic equation. Can I write it as an exponential? If you remember the exponential form, the easiest way is to turn it into exponential. The exponential form of log a base b equal to c. This is b to the power c. Sorry, this is not a, this is x. Let's say x. B to the power c equals x. This was the exponential form of that log equation. Turning a logarithmic into an exponential, it makes it easier. So what did I do? I solved x. X by itself is on one side, the constants are on the other side. Here's an example of it. You have log x minus 1 base 2. Let me change this to x, just to understand better. Log x base 2 equal to 3. Can I rewrite this as an exponential? The answer would be yes. X equals 2 to the power 3. So what is x? Simply 8. If it was x minus 1, so what would you change? X minus 1 would equal 2 to the power 3. Because I can still operate and say this inside log equals 2 to the power 3. So what is x? X equals 1 plus 2 to the power 3. 1 plus 8, which equals 9. So I figure out what is the x value. X is 9. So if you turn a logarithmic equation into exponential, it makes it much easier. So if I had something like log, by the way, you always have to check your solution for logarithmic. You always have to check this number, replace it back into the equation to see if it's a positive number. If I replace 9 in here, 9 minus 1 is 8. Log 8 base 2. It's a positive number inside log, it's acceptable. And log 8 base 2 is simply 3. To do power, what power gives you 8 is 2 to the power 3. So therefore log 8 base 2 is 3. Check your solutions for logarithmic. Here is one more example, maybe log 2x plus 5 equals 0. Okay, what is the answer to this one? You're not given any base. So what does it mean? That means it's base 10. So I can say 2x plus 5 equals 10 to the power 0. 10 to the power 0. Write it as 2x plus 5, 10 to the power 0, simply 1. This is a linear equation. Subtract 5 divided by 2. X equals negative 2. Count as x is negative 2. Do I check the solution? Yes, you always replace it back to see if it keeps the input positive. 2 times negative 2 would be negative 4 plus 5. That would be positive 1. 1 is acceptable inside the logarithmic. And log 1 base 10 is correct. It's 0. So this is an acceptable solution. This is the easiest type of logarithmic equations. There's what if you had two of them, two log equations? What would you do? This is where we learned how to condense logs. If they have the same base, we learned that you can add 2 log and turn it into multiplication. If I have log x base 6 plus log x minus 1 base 6, I can write this as log x times x minus 1 base 6. Because by the properties of log, I can add these two. Minus 1 equal to 0. So what does it mean? It means log x times x minus 1. You can multiply it as well. X times x minus 1 is x squared minus x. Base 6 equals to 1. Now turn it to exponential. What is the corresponding exponential equation? Let me write it here. What is the corresponding exponential? It is x squared minus x, the input, equals not 1 to the power 6. This is always the base for both exponential and logs. Equals 6 to the power 1. So what do you have? X squared minus x equals 6. Move the x to the other side. X squared minus x minus 6 equal to 0. What you have is a quadratic equation. Solve this quadratic equation. We dealt with this a couple of minutes ago. And we figure out two solutions. X equal to 3, x equal to negative 2. Do I accept both of these two numbers? I don't know. You have to check. If I replace 3 into the equation, I get log 3. That's okay. I get 3 minus 1, which is 2, inside the log. So both logs have a positive input. So 3 is acceptable. If you replace negative 2 into the logs, what you get is you get log negative 2 base 6 plus log negative 3 base 6 minus 1 equal to 0. You don't need to keep going on. Just by seeing one input as negative, it's enough for you to say this is not possible. You cannot pick the other solution because it has negative numbers inside the log. Okay, so the only solution that we have in this case is x equals to 3. This is the only acceptable solution. So if you have multiple log equations, you can combine those log equations. Here's one more. You have 3 of them. What you can do is, let me write this equal. You can move everything to one side. That's one way. And combine them together. Or you can say, okay, let's combine these two first together. Let me write this as a different color. You can say ln x plus 6 equals ln x plus ln x minus 4. That's the same as ln x times x minus 4. Okay. You can move this to the other side and divide. But here is something that we learned last time. You have 2 log ln's on both sides of the equality. There is nothing else. So what you can say is you have 2 log equation with 2 log expressions on both sides of the equality with the same base. So what can I say is the inputs must be equal to each other if the logs are equal. X plus 6 must equal x times x minus 4. It makes the work much easier instead of going through dividing, then turning into exponential. Sometimes it's possible. Here, this is again a quadratic equation. X plus 6 equals x squared minus 4x. Move everything to one side. Continue here. X squared minus 5x plus 6 equal to 0. X minus 3, x minus 2 equal to 0. What is the solution? X equals to 3 and x equals to 2. Just because the numbers are positive, like 3 and 2, it doesn't mean that they're acceptable. So what you do is you check these numbers. Let's try to check this. If you replace a 3, you get ln 9 equals ln 3 plus ln, what is this? Negative 1. So 3 is not acceptable. If you try, because you have a negative number inside the log, this is not acceptable. If you replace 2, what you get is ln 7 equals ln 2 plus ln negative 2. Again, you have a negative number inside the log. This is not acceptable either. So what does it mean? That means this equation has no solution. Unless I've made a mistake somewhere. But I think this looks correct. Let's double check. You can combine these two logs, write this product. You can compare the inputs. These two must be equal to each other. Do the product x squared minus 4x. That looks right. You have minus x. Oh, this is, sorry. Here's, yeah, if this is supposed to be plus 6 here, that means this is supposed to be minus 6. This is supposed to be minus 6, not plus 6. But if this was negative, let's say this was negative, then our solution would have been correct. These numbers would have been a negative 3 and negative 2. You'll see that neither one of these solutions would be acceptable. But I made a mistake. So here, let's try to solve this equation again. Let me rewrite this. I made an error at the end. So let's try to do this. ln x plus 6 equals ln x times x minus 4. This is where we ended up. And let me fix my mistake. Yeah, sometimes if you do it in your head, you make mistakes as well. Okay. As I said, x plus 6 equals x squared minus 4x. This would be the inputs, check the inputs equal to each other. So what is the equation? The equation is x squared minus 5x. Here's the mistake that I made last time. I wrote plus 6, but the correct is minus 6. I moved the 6 as well, subtract the 6 to the other side. So now the factor is x minus 1. Sorry, x minus 6, x plus 1 equal to 0. There we go. Now we have two solutions, x equal to 6, x equal to negative. Are they both acceptable? So no, we have to check. Where do we check? We do not check into this equation. You go back to the original equation. The original equation is ln x plus 6 equals ln x plus ln x minus 4. You never check it in the middle equations because it's you've changed those equations. So you go back to the original equation to see if it satisfies this equation. So if you pick 6, replace it in the equation. This would be 6 plus 6, 12. That's okay. ln 6, that's okay. ln 6 minus 4 is ln 2. So it is possible. This is an acceptable solution because all three ln's will give you a positive value. But if you try the other one, if I pick negative 1, replace it in the equation, negative 1 plus 6, that's 5. That's totally fine. If you replace negative 1 here, you'll get ln negative 1. This causes a problem. The next term will cause a problem as well. So negative 1 is not an acceptable solution. You'll have only one solution, x equal to 6. That would be the only case. Okay, this would be the basic examples of the exponential and log equation. But before I stop at this point, I want to mention something that is kind of important in case you deal with such equations as well. Let's say sometimes you have 2 to the power x equal to 3 to the power x minus 1. Now what you have is two exponential equations. This is in the case when you're dealing with two exponential equations. exponential, two exponentials, two or more. Normally, two of them is the problem. 3 would be super difficult to solve. So here, if you have this equation, 2 to the x equal to 3 to the x minus 1. What we learned is, if you're dealing with exponentials, you can always take a log from both sides of the equality. So I can take a log from both sides. Log 2 to the x equals log 3 to the x minus 1. But you had the option to pick the base. What is the base that you want to pick? You can pick base 2, you can pick base 3, you can pick base 10. Let's try to pick base 3, for example. Okay, can I simplify any of these logs? I can simplify this one. Log 3 to the x minus 1 base 3, that is simply x minus 1. How about log 2 base 3 of x? What is that? By the properties of log, if you remember, you have log x to the r base a. You could have dragged that exponent down and write it as a coefficient, log x base a. So if I have an exponent, in this case x, I can drag that down and write it as a coefficient. So I'm gonna do that and say this is x times log 2 base 3. Okay. So what do I have? I have x times, I don't know what log 2 base 3 is, but I want you to see the idea. Let's say if instead of log 2 base 3, it was 0.7. You had 0.7 times x equals x minus 1. How would you solve this? Is you move all the x's to one side. You say x minus 0.7x equals 1 or something. Then x minus 0.7x, this is 1x minus 0.7x. So you'll get 0.3x equals to 1. And what would be x? X would be 1 divided by 0.3. Right, so this would be the operation. So what you have here is log 2 base 3. Log 2 base 3 is just a number. This is just a number. So what do I do is I'm going to operate exactly the same way. I will move the x's to one side and every other term to the other side. So I'll move x log 2 base 3, there is a multiplication here, minus x equals negative 1. Okay, these two terms now, they have an x in common. I can factor out that x. What is left is log 2 base 3 minus 1 equals negative 1. Remember, if you factor the x, there is negative 1 left here. Don't forget that negative 1 is a coefficient of the x. So what is x? You can divide both sides by this parentheses. It would be negative 1 divided by log 2 base 3 minus 1. This is the answer. I solved found x by itself. Everything on the other side is independent of x. This is all constant. All these are constant. Right? So my solution is this number. I don't know exactly what that number is, but you can use calculator to give a decimal value to it. Okay. So if you're dealing with exponential, you can always still go through the same process, but what you need to do is you have to deal with this idea of dragging down the exponent as a coefficient. Let me try to show you one more example of this in case. I don't know if the homework go through this, but I just want to make sure that you guys have seen it. So something like e to the power 2x minus 1 equals 3 to the x. How about plus 2? It looks like a good question to deal with. So let's take a log from both sides, and I'm gonna pick ln. It's optional. You can pick whatever you want. I'm gonna pick ln just for simplicity. I can get rid of the e. Normally it's easier to get rid of the e. The numbers are easier to see. Okay, so what does the left hand side turns out to be? Ln and e will cancel out, so you get 2x minus 1, right hand side, I can drag down the exponent as a coefficient. I can say x plus 2 times ln 3. Again, use a parentheses. Sometimes it's important that you do not make this mistake. ln 3 is multiplied by this whole thing. So let me distribute x times ln 3. You'll get x ln 3. 2 times ln 3, 2 ln 3. Why did I distribute? Because I want to move all the x's to one side. So if I move all the x's to one side, what do I have is 2x minus x ln 3. X ln 3 is one term. And I add the 1 to the other side, equals 1 plus 2 ln 3. Okay. Left side, what do they have in common? X. I can factor out the x. X times 2 minus ln 3 equals 1 plus 2 ln 3. How do I figure out x by itself? Divide both sides by that parentheses. X equals 1 plus 2 ln 3 divided by 2 minus ln 3. And I solve for x. Everything else on the other side, these are all constants. If you want the decimal value, you can type it in the calculator. It's nothing different from the other example. It's just more work. You isolate the x's, factor out the x's, and divide by the coefficient. Okay, I think this is good enough on the topic of solving exponential log equations.